Hello students. So next, welcome to the next session of part A. That is, in this session we are learning about the next circuit is about uh, transmission gate. Transmission gate is one of the electronic circuit which is used in various application. It is a experiment number 3, transmission gate. So here also we are writing the Verilog program. Is tools required is again same 12.1. Transmission gate or analog switch is defined as an electronic element that will selectively block or pass a signal level from the input to the output. Okay. Next, the solid state switch is comprised of PMOS transistor and MOS transistor. When the voltage on node A is logic 1, the complementary logic 0 is applied to node to active low A, allowing both the transistor to conduct and pass the signal at the into the out. When the voltage on node is active low, A is logic 0, the complementary logic 1 is applied to node A, turning both the transistor off and forcing the high impedance condition on both in and out nodes. High impedance condition represents the third state, that is, we have three different states in any of the digital output: high, low, or high impedance, that the channel may reflect downstream. This is the symbol of the transmission gate, where we have two connected PMOS and NMOS transistor. Depending upon the control value, the input is passed to the output. So this is the program what we need to write for to get an output for the transmission gate. Module trans, so three input, to one input is for the input, and this is a control input, and y input, because E and control are the input. Output register, inbuilt register it is to store the values, always depending upon the value of the control. If the control is 1, then output is assigned to input, else it is assigned to high impedance n module. So this is the test bench program. So different values, input values we are assigning, and with some control values with the delay. Okay, this is the waveform what we'll get. You can observe here. Suppose whatever the input we have taken, with respect to that it will give an output. Okay, so high impedance, if it is we are not giving any control, depending upon your control input it will give an output. If you give the control input as a 1, then it is in a high impedance state. If the control input is low, it will give a high impedance state. If the control input is high, it will give an inputs. Okay, so that will check in our program. So this is this multiple choice question. NMOS device was formed in p-type substrate of the moderate doping level, and testability, which terminology used to represent or indicate the formal evidence of correctness is verification. So which among the following is a wait statement execution causes the enclosing process to suspend and then wait for an event to occur on the signal is wait on XYZ. Which among the following EDA tool is available for design of simulation? That is D. The answer is for this is for D. So you can change this, which Xilinx 12.1 ISC we are using. Next, transmission gate consists of both NMOS and PMOS. These are some of the uh, questions what we can see in a Viva. Next, we'll learn how to run the program in Xilinx. Has change on the disk, would you like to reload? Yes. Okay, if any changes are there. So the as usual the procedure is same: file, close project, file, new project. Here we are writing the program for transmission gate. Write it as a tr trans 81. trans 81. Next. Once again it will give the device, package, synthesis tool, simulator, preferred language. So go to next, finish. After this go to project, new source, Verilog module, the name you give, trans trans 21, Verilog module trans 21, module name it will select. Next, so we have a two inputs, that is A comma C and T control input, and we have an output of Y. Okay, so select it as an output. Next, finish. So this is my program. So for execution purpose I'll take the program what we have already stored. So this is the program what we have for the to execute the module, the transmission gate, the input what we have defined, output, and always depending upon the value of control it will give the input is assigned to the output. Okay, so this is the program what we have, that is if control is 1 then input is assigned to output, else the high impedance state will be assigned to the output. So just save. We have some error, go to check syntax. So if any error is there, just you can remove, just see this in which line the error is there, line 28. Okay, so for this you can, instead of this you can give it as an high impedance state, bit value you can directly assign the high impedance value as Z. Z has not been declared. Spice is assigned with the capital Z. Inbuilt function has to be there. Cap Z. We'll try out with the cap Z. Z has not been declared. So this is the inbuilt function. Just to take even a single quotes. Small Z. So this is the program what we are looking for, the transmission gate, that is module TR, the input and control input, and the output Y. Okay, output Y we are taking, and here input I and S we are taking. So here if the particular control input what we are checking, if it is 1 then the input is assigned to the output, otherwise it is assigned with the high impedance value. So once this check syntax is over, just go to program, new source. Here we will be writing a test bench program for this, that is trans 81 underscore tb. Okay, next finish. So simulation, select this test bench program, ISA simulator. Before that we will give the sum of the values, so that also we can take it from the test bench program. After that initial begin only we need to give the values. So for every edition of the program, just save and go to simulate behavioral model. So run for some 10 nanosecond of delay. So you can observe here when the so here I have S is a control input. Depending upon value of the S, when S is 0, it will be in a high impedance state. When S is 1, what is there in the input, that will be assigned to the output. So you can observe here. Once again, when S is 0, that will be in a high impedance state. So this is how we can compare the transmission gate output with respect to the program what we have written. Okay students, thank you. We'll meet in the next session.